Hi, everyone. Welcome to Riot's Lunch and Learn series. My name's Caroline Griffin. I am Director of Operations for the Riot organization. And you found us. This is the place where we feature all of Riot's partners and some educational content. We're super excited to have Joe Ward, Director of Sales and Business Development for EPs, with us today to talk about leading the way to energy autonomous edge computing. Before I hand it over to Joe, I just have a couple of quick reminders for you all. Please do keep yourself muted throughout the presentation. If you have any questions, I encourage you to use the chat box. We will, if we have time at the end, allow you to unmute yourself and ask questions in real time. And if we, for some reason, can't get to your question before the end, Joe will follow up one-on-one, so don't worry about that. This presentation, as you may have heard, is being recorded. It will be posted to Riot's YouTube channel and then shared on the meetup group where you registered. And then my last reminder is the best way to view Joe's presentation is in speaker view. That'll give you a nice large view of Joe's presentation, and then Joe on the right, who has some live demos for you today. But without further ado, I'll hand it over to Joe. Joe, thanks for being with us today.
Thank you, Caroline. Okay. And thank you, everybody, for attending this presentation. I hope you find it interesting. It's a really exciting topic. Energy harvesting is a really exciting area right now. It's been around for a while, but there's been a lot of innovation lately, making it very small and efficient and affordable for many applications. And as you'll hear in the course of the presentation, there's a lot of issues with batteries these days. They never last as long as they're supposed to. They fail at different times. The disposal issue is becoming a major nightmare for this industry. So a lot of people are driving towards using ambient energy as a way to either extend the battery life or replace the batteries altogether. So again, as Caroline said, I'm Joe Ward, the Director of Sales and Business Development with EPs. One quick slide on who the company is, where it's an acronym for Electronic Portable Energy Autonomous Systems. We're a fabless semiconductor based in Belgium. Our executives came out of the university system with PhDs and a lot of patents in ultra low power semiconductor technology that they've applied towards energy harvesting. So it's a really exciting area. Our mission is really to harvest energy from the environment and consume less energy in the circuits, so that you kind of come at it from both sides, so that we can make sure that the designs are very efficient, very low energy, and hopefully remove the need for batteries. So our core competence is really low power technology. We've got some unique ways that we do ultra low power semiconductor technology, and it's as you'll see in the course of this presentation, there's some unique attributes to our device to make it different from anything else in the market. But basically, we have a family of power management ICs. We call it AEMs, Ambient Energy Managers. And then you actually in Q1, we'll be announcing a family of MCUs, ultra low power microcontrollers. But for the right now, we're focused on the energy harvesting through the AEMs, and that's what the course of the bulk of this presentation will be focused on. We have a family of the AEMs, and the main three devices that have been out for quite a while are shown here. There's a bunch of new ones that just came out that I'm going to show you in a later slide, but we have devices for each type of energy source. Solar or photovoltaic, or as we call them, PV cells, are the most popular because light is pervasive. It's pretty much anywhere between outdoor lighting, even on super cloudy days, you can still get ample light. And there's been a lot of innovation with PV cells that today you can, with very modest indoor lighting, still get enough energy from a pretty small PV cell to drive a sensor or to drive a radio. So that's why it's become very popular. But we also have applications for thermal, using thermal energy generators. And we also have devices that work with vibration and RF energy sources to harvest that type of energy. Those are AC sources, so you do need an external rectifier because our device requires DC voltage in. And there's a ton of applications. We go after anything that's low power that uses a battery, but the biggest market for us is an IoT devices, because those are permeating every industry you can think of. Here, we've listed a couple here and tracking is probably one of the single biggest applications, because everybody wants to track things, people, animals, pets, equipment. And so monitoring or tracking assets are really important. And as you can imagine, and this will be the theme of this presentation, if you can imagine all these thousands of trackers out there, it's just hard to make sure the batteries are replaced without having failures or without having downtime. And so if you can put some type of energy harvester into that tracker or into that edge device, you're going to be able to extend your battery life or replace a battery altogether. And that's very, very achievable with the technology we represent today. Just to reiterate, IoT devices are deployed in every market segment in high volume, and they do every type of function you can think of. They sense, they measure, they monitor, they track, on and on. Battery replacement is a major headache to the end user because, as I've said, the cost to go out and replace the battery and then to dispose of the battery can really add up. And energy harvesting is a solution to these problems. One last slide on the problem related to battery disposal. It's a huge epidemic for the industry because there's so many batteries being thrown away, and it's just really bad for the environment. And so a lot of companies are really driving into energy harvesting for this very reason, because they can market as a green or energy environmentally conscious company. And so it's just something to keep in mind when you're considering these options. So again, a lot of reasons to consider energy harvesting. You can reduce your storage volume, you can extend the life of your product, you remove the maintenance costs I just mentioned, but also you can add features. Typically, a lot of people doing remote sensors or edge devices have to really limit the functionality because they're on such a strict power budget. They want to get the maximum power from life from the battery, so they really trim back the capabilities. But if you add energy harvesting, often you can add those capabilities back. You can maybe add that extra sensor, or you can transmit and receive more often. So these are the kind of things that energy harvesting can allow you to do that maybe you couldn't have done with that tight power budget off a small battery. So what is energy harvesting? At a high level, it's taking that ambient energy and harvesting it and storing it so that you can drive your load, which is a radio or a sensor, or maybe it's a micro, but this is what it's really all about. There's the 4 primary energy sources listed here. As I mentioned, solar is the most popular, but also vibration or electromechanical is another way to create energy to drive these type of products. Thermal, if you have a temperature gradient of more than a handful of degrees, that often is enough to create enough energy to drive a circuit like this. And RF is another way to do it. You can harvest RF. It's tricky. RF can be black magic, but if you know what you're doing and if you have expertise in building matching networks with specific frequencies and specialized antennas, you can harvest energy through RF. And so our device fits in the middle. It's an AEM, and what we do is we ensure we get the maximum energy, the maximum power from the harvester. And that's really important. As you can imagine, you want to make sure that this is a very efficient circuit and that you're getting the maximum power from the source so that you get the biggest bang for your buck here. And so what our device does is it sits in the middle of the harvester and the storage element, and it gets the maximum power from the harvester. It enables an ultra low startup. So we call it a cold start, but most of our devices start at 3 microwatts of energy from the harvester, which is very low. Some of our newer devices actually even have a lower capability there. We protect the storage element so it doesn't overcharge or over discharge. We directly supply regulated voltages to your application. And there's a bunch of other features we have, but these are the main functions of the AEM in the energy harvesting circuit. So as I mentioned, these are the main 3 devices. I'm going to tell you about the new ones in a minute, but just at a high level, these are very easy to use devices. There's no software involved. There's some configuration pins that you use depending on the harvester, depending on the storage element and the voltage levels required. But they're very straightforward to use. So this just summarizes those main features. The cold start, 3 microwatts or 380 millivolts. The global leakage, which shows how efficient the device is. The maximum power point tracking, which is a very unique way of making sure we get the maximum power from the source, the storage element protection, and then the LDOs for driving the different voltage levels out to your hardware device. So this is the main functions for the, the, the AEM. Our goal is always to replace batteries. We want you to be fully autonomous so that the device will work 24/7 without ever having to worry about battery. And that often is very achievable, but sometimes it's not. Sometimes, depending on the environment, sometimes you're going to be in the dark for extended periods of time, or some people require a backup battery or a fixed cell battery. We call it a primary battery, and our devices have accommodations for that. Most of our devices can manage a primary battery as a backup. So, so to dive into just a little bit more detail, you see the block diagram for the device up in the top right. The functions I talked about. There's we have the cold start capability, which allows the device to turn on at a very low energy level to boost the energy to the storage element, to make sure it doesn't, to manage the storage element, and then to drive the load. And then you see the capability for the primary battery there also. The device has a very small footprint. These initial devices we have require 7 external passives. So really, the complete energy harvesting circuit, for example, for solar would be the PV cell, the AEM, the power management device, a storage element of some type, and I'll talk about those a little bit later. But that can be a rechargeable battery or a supercapacitor, and then some external passives. That is the complete energy harvesting circuit, and it can be very small and very low cost, and it can be very efficient. So these devices require 7 passives. There's 5 caps and 2 inductors required, and there's again some other features. For example, we have dual super cap balancing. So a lot of times people like to use dual super caps for their storage element, and we have a way of managing that to make sure that they're both used at the same level, so the one doesn't drain before the other. There's an open circuit and constant impedance MPPT tracking. So a lot of capability in these devices to make sure that your energy harvesting circuit is very efficient and gets you the maximum power for your application. So this is a picture of a little demo unit we have, which I don't know if you can see my unit here. It's about 2.5 inches by 2.5 inches and maybe 1/3 of an inch thick. It has a photovoltaic cell in the front, and it has some sensors on it for doing humidity, temperature. It has a lux meter so they can actually detect light levels, and it actually has an accelerometer also, so it detects movement. But it has no battery. It has a photovoltaic cell and a supercapacitor. And if this device gets approximately 8 hours of pretty modest indoor lighting over a 24-hour period, it'll run forever, 24/7, because there's enough energy stored during the dark times to drive the radio. This one uses Bluetooth radio, and it sends that data every 10 seconds to the phone. And again, if it gets about that amount of light, that keeps it charged up, and it never needs to have a battery. And that's what we're trying to demonstrate, is that a simple little device like this can be fully autonomous quite easily with a small PV cell, even with modest indoor lighting. So we have different versions of this little unit. We actually have a LoRa radio in one unit that it doesn't quite transmit as often as Bluetooth, because LoRa takes a little bit more energy, but it'll transmit about once an hour. And then we also have a Cat-M, a cellular version, that'll transmit a couple times a day, because Cat-M does require a lot more power. Just with the configuration we selected, those are the power budgets, the restrictions that we have. But you can use a bigger photovoltaic cell, you can use a bigger storage element, or there's different ways to optimize the circuit so that you can accomplish the goals of your application. Okay, we have evaluation kits for every type of device we have. You can see again, the picture there, you can see my little demonstration board here, but these boards have jumpers and different types of configuration pins so that you can try different types of harvesters, different types of storage elements. You have places to measure voltages so you can see what type of voltage you're getting from your source or from the load. So they're very, very easy devices to hook up to determine your power budgeting and to get an idea of what's required for your application. There's a lot of different form factors for the boards. I'm going to show you some at the end that actually come bundled with PV cells and things. But we have, as mentioned in the slide, a mini version, and actually we have a version that has an external boost or external DC to DC converters, so that you can, if you want to drive a higher load, you can use an external DC to DC. So a lot of different tools and a lot of different, guides. We have data sheets, we have app notes, we have user guides for the eval boards. A lot of ways to make sure that your experience is easy and favorable with these products. So to go into a little bit more detail on the devices, the one device this is the 1941, which is for solar or for PV cell applications. You can see some of the specifications. I mentioned the 7 passives required. It comes right now in a QFN 28, which is 5 by 5 millimeters. And by the way, you can get these devices through our distributor channels and the eval boards also. Mauser is our main distributor, but also DigiKey has a lot of the eval boards today, and they'll have the components in January. So you can see some of the specifications here. The way that for this device, the maximum power point tracking is done every 5 seconds. You can see the leakage, and then some of the information on the device, and then on the eval boards that are available in the user guides. So there's this device. The core architecture for these initial devices is the same for the different energy sources. There's just some minor changes on the harvester and on the MPPT tracking and on and some of it, but it's the same package, the same external components required. And then this device is for electromechanical or vibration, and you can see the MPPT tracking has changed. The cold start capabilities changed a little bit. Some of the specifications are slightly different, but basically it's the same core architecture. And this one is for RF. Our device is for doing RF harvesting. As I mentioned, it is tricky, and you do require a matching network and an external rectifier. But there's ways to harvest any frequency. Our device is really ultimately frequency agnostic. It just a matter of getting the right matching network and antenna. But we can harvest from manage the power from any type of RF source if you got the front end set up correctly. But we do have different eval boards, and we did select different frequencies for those so that you could manage, do the power harvesting for specific frequencies. So for example, I think it's listed here, you'll see we have sub-gigahertz frequencies, 868, which is primarily for Europe, and 915 for the US. A lot of radios work in those ranges for doing IoT tracking, things like LoRa and Zigbee and others. But we also have an eval board that's set up for 2.4 gigahertz. So that if you wanted to try to harvest frequencies in the Wi-Fi or some of these other 2.4 frequency ranges, those eval boards are available for you to do that. Okay, so I mentioned the initial products that we've had for quite a while, and they're listed in the green at the top. And those are what we refer to as a boost architecture. But we just recently, in the last few months, introduced all these other devices below. They're complementary devices, so it really just depends on the type of architecture you need and the type of voltages you're doing in and out of your circuit that are going to determine which is the best of these architectures. You can see the buck boost or more of a battery charge application. And then this bottom one here, the 10900, is really targeted. It's an ultra low power device that's targeting applications like wearables, where you're going to have a very small input range and output range, and you're going to be more focused on just charging the battery. So this is the portfolio today. All the eval boards are available through the distributors, and we have prototype quantities available of all these devices, and they'll be in production in Q1. So they're all ready to go for usage. And to go into a little bit detail on the devices themselves, this is the 10330. It's what we call a single output buck boost AEM. It'll do up to 7 solar panels, and you can see some of the specifications on the right. The cold start's a little bit lower than what we had mentioned before, 275 millivolts and 3 microwatts of input power to turn the device on. You can see the MPPT sensing is set up a little bit differently. It has a much smaller footprint. It only requires 3 capacitors and then the 1 inductor. You can see the block diagram on the left. But so basically, the top left gives you an idea of, again, the energy harvesting circuit. You have your source, the harvester, the PV cell, and then if you need, you can have the primary battery. And then you have the device here, the power management device that will require the few external passives. And then you have your storage element. And you can see, if you can read the fine print there, the types of storage elements, a lithium ion cell, or many different types of supercapacitors, dual supercapacitors. And so you need that. And then you have your circuit. And your circuit can be, some type of sensor, some type of radio, but we can drive that directly from our device. So the type of applications this device is targeting is really things like smart home, different types of IoT sensors, which really serve pretty much every market. But industrial automotive is a good target for these type of applications, and smart building. So this next device is the one I'd mentioned for a minute there earlier. It's the 10900 that is ultra efficient. It's targeting for solar or light. It's more of a battery charger type application. So you can see the block diagram here. You have your photovoltaic cell, and then this device, and then the storage element. And then down below, you can see that there's only three external passives, the capacitors and the inductor. This one comes also in a very small package, a CSP package, which is 2x2, which is extremely small. So that's why it's really a good target for things like wearables and some medical applications that really have a small footprint required. Also for asset trackers and certain types of IoT sensors. But again, very low cold start, 250 millivolts, 4 microwatts. You can see some of the specifications here, including the MPPT ratios. And it does have the constant impedance matching, as we talked about earlier. So again, I'm not going to dive into too much technical detail. We've got data sheets readily available on our website, and then we're going to take some questions here in a minute. If you have some specific questions, maybe we can address them. I see some questions building up now. Let me just.
Yeah, there's a few, Joe. Do you want me to feed you some?
Well, I am actually a little ahead of schedule, so yeah. Why don't we just do a couple now, and then we can pause and then I'll finish up, and then we can do the rest then.
Sounds great. We'll start at the top. A question from Derek. What are the lux requirements for your PVs?
So, okay, good question. So again, we don't do the photovoltaic cells ourselves. We work with a host of partners. I have a slide coming up. I'm going to show you a list of some of the partners we work with, and they have a wide range of capabilities. They have, depending on your application, you pick the best PV cell for your application. Some are targeting more outdoors, some are more targeted for indoors. Some have flexible cells, some are rigid, some are more environmentally robust, some are a little bit more efficient or a little bit lower cost. A lot of trade-offs, but we have a lot of partners that do these type of PV cells. And as I mentioned, like this one, for example, in my demo unit, this one works down to about 200 lux, which is pretty good, pretty low level of indoor lighting. But there's some new ones that have just come out that I'll actually mention a little bit later that actually are advertising capabilities down to 50 lux, which is pretty dim lighting. And so they can generate enough energy to drive a radio, even at that low light level. Of course, outdoors, there's really no issue because even on cloudy days, you're still going to get 500 to 1,000 lux easily. So it's a wide range. It just, to answer your question, it depends on the PV cell you select, but there's been a lot of innovation in this area, and the light levels are come way down, and which helps you to get to a smaller size and even lower light levels. So okay, so next question.
Thanks, Joe. How low power would a sensor need to be to use your harvesters?
So again, how low power? Say that one more time. Sorry.
Yeah, no worries. How low power would a sensor need to be to use your harvesters?
There really is no limit on the low side. Where there's an issue is on the high side. If you have a load or a radio or sensor that requires too much energy over 5 volts, that's where you would need some type of external DC to DC converter so that you could manage that higher load. But if it's low, it's very easy to run directly from our device or from storage element. There's a lot of different configurations, but low power is not the issue. We support again anything from very, very low levels up to 5 volts on the output. Okay, next question.
Awesome. Thanks, Joe. Do you have any more generic ag application examples? This gentleman, Charlie's thinking smart ag is in the Linux Foundation Edge products.
Yes, no, that's a great target market for us because, as you can imagine, sensors out on farms or on animals are hard to manage, and so if you could, most of them are exposed to things like light quite, prevalently, quite easily. So it's a great target market for us. We work with several companies that are building sensors. One of them is on our website. It's a company called Movement. They're Moove, Movement, a kind of unique name, but they're on our website. But so there are others. But I suggest if you're interested in some specifics, please contact me afterwards, and we can share with you some of that information. Okay, maybe one more.
All right, yeah, we'll go for one more right now. This one's from Derek. Can you share some success stories of applications?
Gosh, yeah, where can we start? Several of them are on our website, but there's a ton of them. It's basically, things like wearables are driving a big part of our business because there's a desire to extend battery life as much as possible. So we've had successes in that area. We've had successes with asset trackers, with ESLs, which are electronic shelf labels. That's a very high volume application. These e-signs are going into retailers because they don't want to do paper displays anymore. And so that is a huge application that we have very much success with. There's automotive. We're working with a company that's on our website that does windshield tracker. I mean, it uses solar, it mounts on the windshield, and it detects chips or scratches to the windshield. It's really good for fleet management type applications or rental cars. I could go on and on. I suggest to take a quick look at our website where we list a lot of examples of applications and successes, and there's some new press releases on there. But if you have something specific, contact me afterwards, and I can tell you, if you're looking at a specific area, I can tell you about where some of the work we've done in that specific area. Okay, so let me just finish up, and then we'll get back to some questions. I just have a bit more here. This slide shows a comparison of the 4 solar devices we have, and I just put them back to back or head to head here, so you can get an idea of the type of capabilities of one versus the other. And again, the main differences are going to be in the way the MPPT is calculated, and the input voltage ranges, the battery voltage ranges, and then some of the functionality with the LDOs and the architecture. But again, if you have specific questions, we'd love to talk to you about it. What we like to do, we've got a team of apps engineers, and this is what they focus on 100%. So they've got great expertise in working with customers to analyze their application. Look at your environment, look at your power budget, look at the type of storage element that might be best for your application. And by looking at those 3 elements, we can give you suggestions on the type of harvester, the type of storage element, and then ways to optimize the load for your application. So how often you can transmit and receive, and the type of radio you could use, or the type of sensor. So we do a lot of work in this area to help customers decide how to optimize energy harvesting for their specific application. Again, this is now on the vibration and RF side, just a quick slide on how this device is set up. And you can see, again, some of the specifications. I'm going to skip through this because I did cover a lot of this on the last couple slides. So this slide, this is really cool. We work with, as I mentioned earlier, a lot. We sit in the center of the energy harvesting circuit. And so we work with a lot of partners that have expertise in different areas. And it's great because they, as I mentioned, like photovoltaic cells, for example, they all have their uniqueness and advantages. And we work with a lot of these companies to make sure that we understand where they have the best fit. We have evaluation boards that we do jointly with several of them. For example, I can show you this little eval board. It's really thin, it's flexible. This is done with a company called Epishine. It's an organic PV cell, and it has a cap XX super cap on it, but it's just a demo card that they made that allows you to do testing on solar energy harvesting. This little unit is done with a PV cell from Fujikara, and on the backside is an NGK rechargeable battery that's ultra thin. it's solid state. It's really cool. So there's all different types of these kits we have. This one we do with a company called Power Film, and it comes with 4 different photovoltaic cells. And it also comes with a rechargeable battery, a little rechargeable battery, and then one of our small little eval boards. But this kit is available directly through Power Film or through EPs, or you can get it on Mauser. But it gives, so it's one that comes out of the box with photovoltaic cells and super caps, so that you can start testing and play around with different light levels and power levels. But we have a lot of again, these partnerships are great for us because it allows us to have the flexibility of selecting the right partner for the right application. And there's some new ones on here that are really amazing. Some of the capabilities they have, like Ambient Photonics, they've got they're a new company doing PV cells, but they've got really amazing power density levels. So, anyways, if you're interested in getting our feedback on this, please contact us and we can help you select who we think is best for your applications. Down in the middle left are the some of the companies we work with in the vibration electromechanical area. Down the bottom left are the TEGs, the thermal energy generators, and the top right are some of the companies we work with in doing rechargeable batteries and supercapacitors. And so again, they all have some uniqueness, advantages. There's a lot of innovation in that area, so that you can get ultra thin, super small, with pretty good storage profiles. So a lot of options, and this is an area we can help you. There's a couple companies listed here that do RF solutions, Osea and Energis. They're partners of ours that do complete RF solutions. So if you don't want to design it yourself, which can be difficult because you have to have a lot of expertise in this area, you got to know antennas and matching networks, and you got to deal with FCC. But if you want to do RF energy harvesting at distance, at longer ranges, these companies provide a complete solution. It's some really amazing innovation. And so, again, if you're interested in that, we can arrange introductions there. And then down in the bottom right, you see companies that have different types of radio technologies. We work very closely with them to do webinars and reference designs, but for technologies such as LoRa, Bluetooth, Cat-M, Zigbee. So everybody's very interested in trying to help customers get better battery life or eliminate batteries. And so we're partnering up with a lot of these type of companies to help them with their applications. And then last but not least is Qualcomm. We were just approved into their smart cities and their wearables incubator programs. So they're helping promote our technology within their network of partners so that they can help enable their edge devices, their sensors that are part of their networks to be battery free or have longer battery life. So I mentioned the eval boards and kits. Here's one quick slide that shows you we have a PDF that has all these listed, but we also have them described on our website. And as I mentioned, you can get these through Mauser or DigiKey. But the top boards here are the ones that we do directly. And you can see like these 2 pictures here on the top right are the pictures of these eval boards. And they just come with our device and all the passives, and then a bunch of jumpers and interfaces for hooking up the harvester as well as the storage element. And you can see the one right below is an RF board. It has the connectors for doing the specialized antennas that are required. So those are the ones from EPs. But then we have down at the bottom the partner kits that we do. I mentioned a lot of them already. The Power Film, the Epishine. We have one from Panasonic. We have the Fujikara one I showed you. We have one from Dracula, which is a really nice kit. And then we also work jointly with Energis to have a development kit for doing RF energy testing. It's a complete kit with a transmitter and a receiver. It's available through Energis, but again, we can help you get that introduction done if you're interested. So I encourage you to check out our website. This was a lot of data we threw at you, and our website is really nice. It's got a lot of information about applications. It's got videos showing you how to use things, how to get things done. There's data sheets and eval board information for all the products. There's frequently asked questions. There's different examples of applications. There's news releases. So a lot of really good information on the website. Please check it out. And we have sales representatives across the U.S. I know that there's people on this call from all around. I originally thought it was going to be more southeast central focus. So I put this one plug for our sales representative in the northeast. I mean, in the southeast. AEM is a great partner of ours, and they have an office right there in North Carolina. So again, if their information is on our website, but feel free to contact me, and I'll be able to put you in touch with the right representative, no matter where you are in the country.
I'm Ed Bray. I'm here in Raleigh.
Hey, Ed.
Hey, Joe. Doing a great job.
Thanks. Okay, and then just one last slide, and then we'll go back to some questions. So we have we're going to be doing a lot of shows in 2022. Hopefully, COVID allows this to happen, but right now we're starting with CES in January, which is probably the biggest of all the shows. We'll have a booth there with representation there. If you're going to be there, please stop by our booth, look us up, or better yet, even set up an appointment in advance so we can make sure we get the right people for your discussion. But yeah, just keep that in mind. And again, my email is there. Feel free to contact me about anything. If you just want to get some information, you maybe set up a call with an apps engineer, you want to arrange something for CES, you want to get something, some information about our sales representative or whatever, just run it all through me, and I'll be able to help you out. Okay, that's it, Caroline. Can we go back to the questions then? And
Absolutely, Joe. Wonderful. Thank you so much. So we'll roll right in. We have a few questions here.
Okay.
Are gateways required for scaled solutions, or can the sensor transmit directly to the cloud via LTE/Wi-Fi?
So this question pertains to RF energy harvesting, and again, that depends on what protocol you're using. Some protocols require a gateway, like LoRa. You'll have to, but that's really independent of what we do. Think of us as part of the energy harvesting circuit that's replacing a battery, and then you're going to have your sensor, which contains your radio, and you can have whatever you want there. As I mentioned, we support Bluetooth, Zigbee, Cat-M, but so that's going to dictate what type of gateway or what type of communication protocol you need to set up, and it can vary. Bluetooth, you can go straight to a phone, as you probably know. They all have different idiosyncrasies of their protocol requirements, but it varies, and we can help with that. We work with a lot of companies that are looking at power budgets and trying to decide on the radio protocol, and we've got a lot of experience with that, but it's not directly in our domain. We would kind of give you some suggestions and then point you in the directions of what tools to get and what partner, what type of radios to consider. Okay.
Perfect. Thanks, Joe. Question here. Did your company feel any global chip shortages for your products?
No, not really. We're pretty careful about profiling our inventory and working with wafers and packaged product, and we're still kind of small, so we really didn't get hit like some of the big guys in the industry. But going forward, we're extremely careful because there's still long lead times in the industry. So we're working with our foundries. Our biggest foundry is TSMC, but we're working with them to make sure that we are ready for the ramp that we're going to be experiencing in 2022. That's going to be a big year for us because a lot of our customers are going to be going into production. So we're ensuring that we're going to have ample supply, through 2022 and into 2023. The only way we really did feel direct impact from this was a lot of our customers couldn't get other products because of the chip shortages, so they had to delay the rollouts of their products, and that affected our delivery to them. So it's not a direct hit; it was kind of a indirect blow to us. But that was a bit of an impact for us in 2021.
Thanks, Joe. Next question here. Do you have a list of devices such as vibration generation devices that you would recommend for your devices?
We do. Yeah, as the one partner slide I showed, but we've got some other information, and it does vary, as you can imagine. For speaking about vibration or electromechanical, there's a lot of variables there. There's different types of piezos or electromechanical devices. It really depend on type of vibration you're looking at, the frequency of the vibration, and so we can make suggestions available of partners we recommend, but the best thing to do is to contact us and give us some more detail about what we're looking at, so we can narrow down the information and make recommendations that are a little bit better, more specific to your application.
Okay. Thanks, Joe. And I did see that Penny put Joe's email in the chat box. It's also there on the screen, and we'll share it out as well. Thanks for that question. Next question. For the thermal voltage generation, what are the positions of the incoming and outgoing spots for thermal energy?
So again, so we work with a list of different partners that manufacture thermal energy generators, different types of thermal energy harvesters. And there's a wide range. It depends on type of application and where you're going to be able to mount it. But basically, fundamentally, what a thermal energy generator does is it takes a temperature gradient. You have to have a temperature variation, like on a pipe or on a motor or something where the temperature, and even wearables use TEGs because the difference in temperature between skin and ambient air can be enough to create energy. There's been some innovation in this area, and there's one customer of mine is using a product called a Peltier type TEG, and they said with 5 or 6 degrees of temperature variation, they can create enough energy to drive a small radio like this or sensor. But so the answer to the question, it depends. But what you really have to initially focus on is having a temperature gradient available. If you have an application where you can rely on some type of temperature variation on a product, on a surface, on a piece of equipment, on a person, anything that can give you a temperature variation, that qualifies. And then you have to look at some of the details from there. But that's really how fundamentally a temperature energy generator works. Okay.
Perfect. And you answered the second part of that question. So thanks, Joe. I think that's all the questions that I'm seeing. I'll just, there's a lot of positive feedback here. Awesome presentation. Thank you, Joe. If there are any questions that I missed, I'm sorry. Please feel free to unmute yourself. We'll leave it open for another minute or two. Just a reminder that this presentation was recorded. It'll be posted to Riot's YouTube channel and then shared via the meetup group where you registered. And then if Joe is comfortable with sharing his slides, I'll also share those out as well when I share the video. So I think that is all. Oh, there's one question that just came in. For concrete example, can any of your devices run on a Raspberry Pi?
Yeah, absolutely. We just did some work with some customers. We actually, it was specific to a LoRa application. So the customer wanted to use solar to harvest energy, and then they want to communicate out with a LoRa protocol, and they wanted to do it on a Raspberry Pi. So we actually worked with a partner company of ours, Semtech, that is kind of one of the owners of the LoRa protocol, and they kind of recommended a Raspberry Pi. I think it was I forget the name of the company that did the Raspberry Pi. But anyways, we were able to configure a sensor for this customer so that they could, use the energy harvesting for a sensor application, and then use this Raspberry Pi for their protocol for the radio transmission back to their gateway, their main hub for the data. So the answer to the question is yes. There's ways to do it. We've got some experience in doing it, and if you're interested, again, contact us. We can kind of give you some guidance in that area.
Awesome. And it looks like I misread this individual's question, not on, but run power the Raspberry Pi.
Oh, so, well, so yeah, again, if I understand the question, yeah, our devices are really we're trying to be energy autonomous, we make these devices fully autonomous. So no power connection will be necessary to this sensor or this edge device, or, typically people are gravitating towards batteries, and you're just putting a battery in it. But they're realizing that there's issues with batteries, so they're trying to power them with ambient energy sources. So you could consider supplemental energy from a Raspberry Pi or some other source, but then that kind of negates the need for energy harvesting. If you've got some type of connection available or some type of power source available, to think of like these sensors going out into factories or buildings or smart cities or farms where you just can't connect them, and when you're deploying them at scale, going through and replacing all those batteries and disposing of all those batteries is a major problem. Those are the best targets. Just put a small photovoltaic cell or some type of harvester on there, and it'll get you the energy you need, and you'll never have to worry about it. That's the goal.
Thanks, Joe. And one more question just came in. Does your website include reference designs?
Yes, yeah, there's some on there. We've done some with some of the partners. There's some that are available by request, for different radio technologies and things like. So the answer is yes. If you don't see something you need on the website, contact us and let us know, and we'll let you know what we have available. And but yeah, we do have reference designs for different applications.
Awesome. Benjamin, if you have here we go. Benjamin has a question. I think I saw it listed for the RF in the presentation. Did I misunderstand? I'm not sure about that question, Benjamin. We can connect you directly to Joe to get some clarification there.
So we do support RF energy harvesting. And as I mentioned, our device is kind of frequency agnostic. So it's just basically, if you're going to build your own energy harvester for RF, you need to set up your matching network, your antenna, for the specific frequency you want to harvest, and then we hook up and can manage the power from there. We do have eval boards that are specific frequencies, so that if you want to do something at 915 or 2.4, we've got eval boards that you can use to play around with energy harvesting at those specific frequencies. They have the matching network and the antennas, and so it's all set up so that you can see what type of power you can generate at different ranges and things like that. It's so yeah, we have those type, and we have an app note on doing RF energy harvesting. So if that's the question, that's
Joe, it's me. I don't know if you can hear me, but yes.
Yeah, I can hear you now. Sure.
It's on the AEM 10900, if that's how you call it.
Yep.
So I think I saw in your specification that it was maybe or maybe not connected to an RF source, but the website calls this one the solar energy harvesting battery.
It's absolutely
charger.
Yeah. I'm not sure about where you saw the RF thing, but it's absolutely a solar PV. It's targeting solar applications, PV cell.
And does that exclude the RF inputs?
Yeah, you can. There's ways that you can actually use this device in an RF application, but you would have to add the specific inputs. It's not tailored for it's more tailored for solar.
It's the only one that's wafer scale, so it's the only one that's 2 millimeters square.
Yes.
Are the others slated to come down to that size?
Yes, we will have an RF device slated in a CSP in 2022, but this is the only one today. You're right. Yeah.
Great.
Okay.
Awesome. Thanks for the question, Benjamin. All right, everyone. I think that's all the questions. Again, please connect directly to Joe or the AEM group. Shout out to Penny and Ed. Thank you for facilitating this presentation, and big thanks to you, Joe. We hope to see you again soon. Stay safe, everyone. We'll see you at the next Lunch and Learn. Take care, everyone.
Great. Thank you all. Thank you.